Greetings, math friends. We are going to look at a problem that has some applications with computer science. We want to demonstrate that the function f of x equals x cubed plus 2x squared plus 2x plus 1 is big O of x cubed. All right, so we have to choose some witnesses. These are specific values, okay? One of the witnesses that we choose is k, such that x is greater than that k value that we choose. And then we will determine what our second witness is. This is some scalar multiple of a function. So what we would like to have is that the absolute value of f of x is less than or equal to c times the absolute value of some other function when we have this condition. All right. If these conditions are met, then we say that f of x is big O of g of x if we have these values, which we call the witnesses. So let's start out and try this and say, let k be 1. Right? So this implies that k equals 1. All right? If we choose this. All right? So we have x cubed here. If I multiply this side by x squared, I'll get an x cubed. So then multiply by x squared. All right. So we have that x cubed is greater than x squared. Hopefully that makes some intuitive sense that an x cubed would be greater than an x squared. All right, so now we want to start to build this situation. So I'm going to recopy f of x here. All right, and we know that x is going to be a positive number, so we can ignore the absolute value for now. All right. So I'm going to rebuild this situation here and try to fit as many x cubes in it as possible. Oh, I forgot a square here. Okay. So x cubed is equal to x cubed. We're allowed to have equality here. So the first term is fine. It's equal. But I want the second term, I have to have equal to this or larger. So thinking of having an x cubed in here, because we know x cubed is larger, I can turn this into 2x cubed. We know from this that x squared has to be smaller than this. If I have a 2x, I multiply this by 2, then we would have the condition 2x cubed must be greater than 2x squared. So that condition, we're guaranteeing that this is larger. Now for x here, all right, we know that x is larger than 1. Okay, if we multiply both sides by this, we know that 2x is larger than 2. Okay, we're going to go ahead and replace that term 2x cubed. Shouldn't hurt anything. And then again, we know that x is larger than 1. So we can replace this with an x cube as well. One of the reasons that we like to do this where everything is an x cube is because this right hand side here, This is all like terms now. So if you think about your Algebra 1 skill set, these are all like terms, so they can be added together. So we can say that there is some sum here. So we have 1 plus 2 is 3, plus 2 is 5, plus 1 is 6, right? And then the x cubed goes with that. And this is what we're going to call our C value. This is our other witness. All right. So the K value that we chose up here, that was our first witness. And this value is our second witness. We've started out with f of x right here. And we know that it is definitely less than or equal to this thing, which is equal to this. So we have the function x cubed would be g of x, and then it's being scalar multiplied by a c value, which is 6. All right, so we've met this condition. All right, we can kind of treat this as a bit of a proof now. We were told to demonstrate that f of x is big O of x cubed. This is our definitional idea of what that means. We have chosen a value, looked at the consequences here, and now we can conclude that if k equals 1 and c equals 6 are our witnesses, we have met this condition here. And we have shown that f of x is strictly less than this system here. And so we can therefore conclude that f of x is big O of x cubed. Sometimes there's a notational equal sign here, depending on where you might see this written. If you see the equal sign here, this is not an equal sign in the strict definition of equals. It implies that the inequality has held. Okay, so be careful about that. Linguistically is, in English, means inequality, but for this situation, it means that the inequality holds from the definition. I hope this has been helpful to you. Hopefully you find some mathematics in your area of the world that you can share with others. Cheerful Calculations.